This video is in relation to these MCA fast wide differential SCSI cards that were actually original equipment on RS6000 machines. Only the external port is differential SCSI. These two are actually SE, single-ended. Now I have got two of these. Reason being, I screwed up the first one, and I'm going to let you know what I did so you don't do it as well. Yes, you can use these in PS2s, and they're pretty damn fast. But there are some gotchas. RS6000 machines do not have SCSI BIOS on the SCSI cards. What does that mean for a PS2? Well, PS2 can still use it as long as there's another card or onboard SCSI that contains SCSI BIOS, because only one card needs to have it and only one is used. So this cannot be the primary and sole controller in something like a Lacuna, which I've got here. It is working currently because I've got two SCSI cards in there. I've still got the Spock Prime in there, and I'll show you that now. So the Spock Prime is sitting there down at the bottom there with my homemade cable. I've never upgraded that. That's still only 512K of cache. And this is the other fast wide differential card. Now, of note, there are two versions of these cards. This is the enhanced version. Specifically, I'm talking about the non-enhanced version. I believe you can actually downgrade the firmware to the PS2 version that contains SCSI BIOS, and that's going to be like Rev 58 or Rev 71. The difference between the enhanced card and the non-enhanced card is the microcontroller. These run at 40 megahertz. It's an enhanced version AMD microcontroller, and the regular fast wide SCSI and the other differential fast wide SCSI, the non-enhanced version, is that it has a 20 megahertz MCU, a more basic version. This cannot run the code from the 20 megahertz card. If you flash this, it allows you to do it. You will brick the card permanently and irreversibly. That is why there are sockets on that card now. That is the only way to recover it. Reason being, you can install the firmware. It validates via accepting the size of the file and then writes the checksum bytes to the memory so that it actually boots beyond the boot block. And as soon as it starts executing code in the main firmware area on those flash chips, it locks up rock solid. There's no access to the serial console. It's completely and utterly dead. All it will do is identify itself on the MCA bus, so you still have the POS ID working, but that's it. It is completely and utterly dead. There's no way to download the correct firmware to it. You just can't recover other than using a soldering iron and installing sockets. And I couldn't even get that working until I got another card and connected to this one with the serial debug console, and I ripped the flash memory contents, because I know the memory map on these cards. I ripped it all to a log capture. The flash memory starts, as far as the card's memory space is concerned, at C1000, continues into D1000, then E1000 and F1000. Rather than talking about it, I will just show you. So these are the log captures. So this is the C1000 range, and this is what you get. I wrote a little script for Terraterm as well, to just keep doing Ds and endlessly until I got to the end of the range. So C000:FFFF is the end of the C1000 range. And instead of myself going through and getting rid of all of these Ds and dealing with this data, I actually used ChatGPT. I handed it these 4 files, So C1000, D1000, E1000 and F1000. I handed it those 4 files. I told it to remove these Ds, ignore the ASCII, rip all of the hex data, starting from offset 000000, whatever. So starting from 0, not from C1000. And then I simply could deal with that hex file as is, because it gave me an Intel hex file after that request. And not only that, it actually gave me the odd and even split, so I could write them straight to the flash memory. So I recovered the second card with this, I recovered the first card with this second card via the serial console. So I rebuilt the firmware in its entirety. And the VPD and the boot block is all accessible through this as well. Unfortunately now both cards have the same VPD, so they're both reporting the same serial number. I don't know that that actually makes any difference, but anyway, it's working. So that's my little adventure, and I would strongly recommend you do not play with the firmware on these 40 megahertz cards. This particular card that I bought to save the other one came with C7 firmware, and I have successfully upgraded my saved card to C9, so you can switch between C7 and C9 using the PS2 to push the firmware. But definitely do not go messing with anything like 58, 71 or 77. They're all firmwares that are meant for the 20 megahertz card, and they will just brick it. And unless you can solder like I can, you're in real trouble. So my next little adventure, I don't know how successful I will be. I'm going to try and make a custom firmware that actually does contain the SCSI BIOS in it and still remains compatible with the C7 or C9 basic firmware. I don't know that I'll be successful, but I'll give it a go. At least I have a card with sockets on it now, so that's really easy to experiment with. If I do come up with something that works, I will share it, but I'm kind of doubtful. In the meantime, I am going to have the C7 complete firmware image with the boot block firmware and the VPD off this card. I will have this archived, if I can, on the Ardent tool, because I'm sure someone else is going to brick one of those. Because the assumption is they only work on RS6000s, so they're actually pretty damn cheap on eBay. Nobody wants them. And everyone assumes even this internal port is LVD. It isn't. It's SE. And you still have your regular 50-pin 8-bit SCSI port there as well for the edge connector. And that works. It's only the external one that's differential. And it performs damn well. It's just a shame there's no SCSI BIOS or no PS2 equivalent. So you might be asking, what the hell do I want this for? What are my plans for it? Currently I have the 50-pin SCSI 2 Zulu SCSI. They do actually make Zulu SCSI wide now with a 68-pin interface. That's what I'm planning to do. So I'm going to buy one of those. And I'm going to use one of these fast wide SCSI cards. Probably not this one with the sockets installed. Maybe the other one. And maybe I will see if the original rather crappy Patriot SCSI card will work with this one. And maybe I'll just have the convenience partition on this original 100 megabyte IBM hard drive, and then have all the exciting stuff on the Zulu SCSI Wide, running much faster than the 8-bit version down there. So that's what I'm going to do. I do have the other 20 megahertz variety of fast wide SCSI on the way. I found one of those new old stock in the box. I may not actually use that. It is again the RS6000 version anyway. So there is the risk involved of messing around with firmware on that. I think I'll probably just leave that sealed in the box and use these. And I'll probably put this Spock Prime in my P70. But yeah, so that's what the plans are.